Okay, so next we're going to take a look at some particle forces. And let's put this up here. I'm just going to alt click and drag on this and call this particles intro forces. Oops. All right, come inside here, and then we'll do this in a bit of a different way. Just a different way of creating the DOP network or a particle simulation. You can do it within the SOP area here. So press tab and type pop network. So all this is a DOP network, so you can create a DOP network as well in here like that. Okay, and it's just the same thing but with these nodes dropped in already for you. So I'm going to get rid of that, plug that in right into the top. It's you know, you can do it either way. There's no real difference in the result of your simulation. It's just whatever you prefer. I prefer, you know, it's more to do with organization really, but I prefer to work this way. Generally, the shelf tools I think will make a AutoDOP network on the at this area, at this context. So yeah, generate a popnet and basically the same stuff again, pop object, blah blah blah, all the same stuff. So let's take a look at some forces we don't have. So the you know, most common one I suppose would be gravity, which we saw earlier. Let's put a ground plane in here just to again have something to collide with. There we go, and again always left input. Because of this, left input affects right input. You can do mutual, but I think this is more efficient. Okay, so we got gravity as a force. So other very common forces to use would be a pop force. And this can be used to add basically a noise. Okay, so by default, I don't think it'll do anything. But if we push this up, give it some amplitude, you can see we got some movements there. If we turn off the gravity, you'll see kind of the effect. You can use the guide for a sense of the scale of the swirl size, make them smaller for finer noise, or bigger for bigger noise. Okay, and it's just really handy to add some variation onto your simulation. What else? So drag, pop drag is really good as well. So this will well, drag, you know, generally add some air resistance. So kind of slow the particles down. It helps to give a bit of realism to your simulation. Really good. Let me turn that guide off. That's annoying. Really good for when you're doing realistic simulations, you know, like debris and destruction, things like that. Okay, so that will slow your particles down. What else? Let's take a look at the pop attract. That's really fun. Pop attract. So we can use this to give a destination for our particles. So what I want to do, I'm going to leave both them on actually. I'm going to come into my my source, and as I said, when this is on, when this is number one, they emit. When it's not, they won't. So we can use expressions in here to control when they emit and when they don't. And a simple one, we can use $F, which is frame number. And this is kind of a shorthand way of writing a conditional statement. Really simple. So basically this means when the frame number is less than, let's say, 10. Less than 10. True, which will give a result of 1, and when it's more than 10 it will be 0. So if we click this, we see the result, and when it's 0 it won't emit. So you can see that changes to 0. So it's a quick way, you know, so you don't have to keyframe anything. You can just change this number to say, okay, I want points before, and you could do either before 10 or after blah blah blah. So you can control when you're emitting, and it just gives you a little burst of particles there. So we'll stick with that. Maybe let's do a bit more particles. A few more. Let me just bring that size down to 3 again, not 32, 3. Okay. And so for the pop attract, I'm going to come back out here and let's do another test geometry. Let's do the rubber toy. Okay, and just template that. Visualize my rubber toy. Turn off the shader again, move it. Let's do another transform to be clean. Okay, I'm going to move that up and maybe to the right with X, I think. There we go. Just something like that. Super simple. Maybe it might look cool if they're face to face. Let's do that. Okay. And then bring that here and rotate him around. Cool. And then I think, yeah, if we plug this into the second input, we can use that. Oh, we need to scatter points onto the surface as well. Oops. Drop a scatter. There we go. And this pushes up to 10,000. We've got lots of points, a good representation of the surface there. So dive back in here, and then into that pop attract, we need to, tell the points to go to that second input. So we go to points, because we just made some points. You can see here, there again, points and particles. So particles will refer to, if we have another source and another system of particles in here, we can attract these particles to other particles. Or if we want points, it's something on the outside in the SOP, in the geometry level. So yeah, points, we want the second context geometry, okay, which is this. First, second, third, fourth. Okay, and the point, we don't have a point group, so that's fine. Let's see if that does anything. Kind of trying, but not really. Let's try just turning off the pop force and the pop drag. Okay, getting there. So at the moment, there is just the average position of all of those points, which is in the middle, which is no good. So if we turn on the points per particle, and it's using the ID attribute, we don't actually have the ID, any IDs on here. If I'm normal position and UV. So I suppose it's using the point number. It's just generating an ID from the point numbers here, because it does work. Okay, so it's saying, if my ID for this point is 6, it will look for point number 6 on our on this geometry and just go to that. So you can have a bit more control of it that way as well. If you control that ID, you'll control where it goes. There we go. So that's looking a bit better now. Okay, so we have some forces that we can use to help this out. So we can push the force scale up so it's just going much faster. Okay, we have maximum distance. So if I drop this down, you should only see it's taking just the points from the nose there. And then when I raise it up, it'll, it's how far am I allowed to look for particles. Put that back. Peak force distance. So how far away will you give me this amount of strength? So it's kind of still going a bit all over the place. Let's drop this down, and maybe I think the drag will help to calm it down. So the closer it gets, there we go. We can maybe increase that drag a bit as well. Yeah, let's try that. There we go. So we're kind of getting the form of that shape now, which is cool. And you can add the pop force on top to add some randomness to it. And you can animate those as well. Okay, so you can kind of see the shape, but it's being deformed there. That's actually kind of cool. Okay, so that's that. Let's also take a look at the curve force. So this is really fun. Pop curve force. So I'm going to put that in there. And we need to make a curve. So let's see. Let's just use the circle. Put that there. Oh, I've already gone. Oh, this from my testing when I did it earlier. So make a circle. Let's make it a bit bigger. So we're going to be emitting from here. So I'm lining it up like that is fine. Let's make it bigger again, I think. Like that. And drop it down. Okay, we want it to be a NURBS curve and to be an open arc. There we go. Okay, and then let's plug that into the third input. Let's turn off the pop attract. And in the pop curve force, let's go into the third context geometry, and then we can see a guide. So it kind of looks like a donut. So on the inside, this red line here is our actual curve, and then the outside is kind of the bounds of where the you know, the extent of that force. So we can do that, control that here, drop it down or raise it up, and let's just set that back to default. And then here, these are important values. So follow scale, how strongly do the points want to follow the direction of that? The suction scale, how strongly do the points, sorry, particles, I'm breaking the rule there. Particles want to move towards that, the curve. Orbit, how much force to force the particles around. Okay, and inherited velocity, that I don't really use, but I assume it's kind of copying the velocity of the points on the curve, which we don't have, so I don't think that will work. So let's just turn it on and see if it does anything. Not really. Let's try just turning off these forces. So it's kind of doing it there, going a bit slow. Oh, we got the ground plane in the way. Disable that. There we go. So it's kind of going around slowly. So you can see it's following the curve. They're being pulled into the middle, and it's also spinning round as well. So we can, you know, make them go around a bit faster. Like that. And you can see the kind of inertia of that speed is pushing it towards the outside. So it is kind of a balancing act. So maybe, you know, pushing that up, I'll also need to push up the suction scale to pull the particles back in. And then they kind of start to settle and start going round. This orbit scale, if we push that up, that will push them back out again because they're spinning around the center. There we go, so you can see them spinning around there. It's nice to, again, use some drag and, add some noise. It just makes it a bit more interesting. Add some drag to it as well. Maybe drop that down. And there you have it, really cool.